Okay, we finished up the last video with creating a table of values and learning or reviewing how to analyze that table of values for the change of x and y and the relationship between x and y. So now we're going to move on and we're going to review finding missing values, because sometimes you're going to be given a set of ordered pairs and you aren't going to be given both values. And one of the things we need to be able to do is find the missing value. So I'm going to give you some. I'm going to give you 7, and we don't know the second one. We're not going to know the first one, but we know the y value is 23. I'm going to give you 100, and we don't know the second value. And then I'm going to give you a fourth one. We don't know the first value, but we know the second value is 49. I want you to turn off your video and see if you can figure out what these missing values are. So this one, this, and this. Okay, take a moment, shut off your videos, and when you come back, I'll go over the answers. Okay, let's take a look at the first one. We know that x is equal to 7, but we don't know what y is. So we write our equation, y is equal to 2x plus 3, and you'll notice that I have flipped the equation for this, and it doesn't matter as long as we have them in the boxes correctly. So y is equal to 2 times x, which is 7, plus 3. So 2 times 7 is 14, plus 3 is 17, so y is equal to 17. All right, and the next one, we know the y value, but we don't know the x value. So we know that 23 is equal to 2x plus 3, which is the $3 is that set rate that everybody that gets in the cab is going to pay. So let's get rid of that. Let's get rid of that 3, and this will become 20. If we take that $3 off the total cost, our total cost is now down to 20, and that's 2 times the number of kilometers. Well, 20 divided 2 times 10 is 20, so we know that x is equal to 20. X is equal to 10, sorry, there we go. And so we can fill in this value over here. Now for the third one, we know the x value is 100. And we need to figure out the y value. So y is equal to, and resist the urge to just say, oh, that's 10 times 10, I'm going to multiply this by 10. Take the time to do the equations. So 2 times 100 plus 3 is 203. So I will fill this one in here. And the very last one, we know the y value, but we don't know the x value. So we're going to go back and we're going to say 49, that's our y value, is equal to 2x plus 3. Let's get rid of that set fee, and we know that that's going to be 46. We're going to get rid of the $3 is equal to 2x, and so x is going to be equal to 23. 2 times 23 is 46. Okay, so hopefully you got those right. We could stop at this point and we could solve our problem. Remember, our original problem asked us to look at what it's going to cost to take a 20-kilometer cab home from school. So let's take a quick moment. We can do that one. We can say y is equal to 2x plus 3. And we now know that our x value is going to be 20, because that's the number of kilometers. So the cost is going to equal 2 times 20 plus 3 which is going to be 40 plus 3, which is 43. So our cab fare is going to cost $43 for your parents to get you home from school in our fake cab. So part of this is being able to solve a problem, which we have solved using just the equation. We didn't actually need to create a table of values or graph it to solve the equation, but to solve the problem. But these are things that we do need to be able to do. All right, so let's move on. And now we're going to graph our equation. I'm going to go back and I'm going to pick up my original graph. Let's see if I can actually transport this. And I'm going to copy it just to see if I can actually do this. And I've got enough of it, okay? So I know that I'm going to pick up a color here. I know that x is 1 and y is 5. So here's, when I'm drawing my graph, let's go over a couple of things that are important for the graph. Independent variable is your horizontal axis. Your dependent variable is your vertical axis. Doesn't matter what letters you give them. Independent variable, dependent variable. We need to choose an interval that's going to work, and we need to make sure these are negatives, negatives, positives, and positives. So x is 1, y is 5. So I'm going to put this right here. X is 1 and y is 5. That looks like a 3, but it's actually a 5. Okay, x is 2, y is 7, right here. X is 3, y is 9, right here. And 4 and 11, and I'm kind of off my chart. Now, the next question, do I join these points or don't I? Am I using discrete data, which I would not join the points, or is it continuous data? The question, the way to think about the answer is, if I were to join these points, the line would include these 4 points, but it would include all the points up here and all the points down here. So just for the heck of it, I am going to join the points. And I'm going to start up here, and I'm going to join them just like this. All right. Now, if this is continuous data, then any point on this line is a solution to the problem. If I look at this point down here, right here, can I have -6 and -5 be solutions to this problem? No, negative numbers can't be a solution to this problem because you can't drive a negative number of kilometers, and you can't have the cost of a cab ride be a negative amount of money. So we are not going to join these points, bloop, and we are going to leave them just the way they are because this is discrete data. Not every point on the line solves my problem. All right, now I can still look at this graph, and if I didn't give you the table of values, oops, it's going to be gone here in a second. Oh, nope, that didn't work. All right, we're going to pretend it's gone. I'm going to move it. No, I'm not. It's taking too much time. All right, if I just had the graph, I could still analyze the relationship between x and y. Here are my x values. X is going up by 1. Here x is 1. Here x is 2. X is 3. X is 4. So as x increases by 1, what's happening to my y value? Well, here y is 5, y is 7, y is 9, y is 11. So as x increases by 1, y increases by 2. All right, so you do need to be able to look at the graph, and I can see if I draw a little dotted line. Can I draw a dotted line? Let me see. I can. And I'm going to make it fairly thin. Here we go. And I'm going to go over and up. There we go. So x is increasing by 1, y is increasing by 2. X is increasing by 1, y is increasing by 2. This is a constant. If you look at my ladder, it is the same each time. X increasing by 1, y increasing by 2. And those are all the points that we've covered so far in this lesson. We've looked at using an equation to solve a problem, creating an equation from a problem, understanding independent and dependent variables, making a table of values, finding missing values in a set of ordered pairs. We have used the table of values to graph the equation. We've analyzed the relationship between x and y. So that's an awful lot of work to have accomplished in a short period of time. For the next couple of days, I'm going to assign you some practice and a couple of things that I will mark. So make sure you contact me with any questions.